In this video, we're going to talk about measures of variation or dispersion or spread. Remember, at the beginning of this unit, we were saying that measures of variation tells us how alike or how different our data values are. How different are they from our middle value? Okay, and we have three different measures. So the first measure is range. And range is basically the distance from the smallest to the largest value. It's the difference between the maximum and the minimum observation. It does not capture any variation in between the minimum and the maximum. It doesn't compare it to the center of it doesn't compare the minimum and maximum values to the central or most common value at all. It just says, okay, this is your minimum, this is your maximum, and the difference. Okay, another one is a variance. And the variance is closely related to the standard deviation. And in the next slide, I'm going to walk you through finding each one of them, and you'll see how they're related. So the standard deviation, it takes into the account all of the observations, and it's the preferred measure because it uses measure of the center to compare other values to that measure of the center. All right. So right now, let's take a look at the given 6 values. Says let's read the story. It says, consider the following scenario. Here are the number of sales per day that were made by Kim Ryan, a courteous telemarketer who worked 6 days before fired. So the values, the sales that he made were 1 on the first day, 2 on the second day, 10 on the third, 12, 17, and 18. So this is a population because he was fired after that. That's all of the sales that he made in their entirety, right? So this is a population. And we're going to use this data set to find the range, the population variance, and the population standard deviation. I made a copy of this slide on paper, so let's take a look. So here we are. This is our population. And to find the range is maximum value minus the minimum value. So our maximum value was 18. The minimum value is 1. So the range for his performance is 17 units. So basically, the distance for the largest one from the smallest number is 17 units. Okay, let's jump to population variance and population standard deviation. In order to start, we need to find, we're going to compare each of these values to the center, to the mean of this population. So let's find the mean of the population first. So 1 plus 2 plus 10 plus 12 plus 17 plus 18 divided by 6. So that was 60 divided by 6 equals 10. So the mean of the population equals 10. Okay, then what I'm going to do, I'm going to list all of these values in a column, all of the X values. And then I'm going to find the distance of each of these values from the mean. Okay, so for the first one, it's going to be 10 minus 1, that's a 9. For the next one is 10 minus 2, that's an 8. 10 minus 10 is a 0. 10 minus 12 is a negative 2. 10 minus 17 is a negative 7. And 10 minus 18 is a negative 8. So those are my distances of each of those values from the center, from the mean. Now, the standard deviation is, by the definition, the idea of the standard deviation is to measure differences of each value from the mean, or the distance of each value from the mean. So this should be enough, right, to measure the average distance. We could average the distance, these distances that we got, and that's going to be our average, right? Right? Try it. Well, if you tried it, you may have noticed that the negative values canceled out the positive values, and you got a 0. And that's what you're supposed to get, because 0 is the true average, right? The average distance of an average from an average is a 0. Anyway, so the distances should be positive. And there are two ways to make those numbers positive. The most obvious one is to take absolute value, because we learned that in math class that the absolute value is actually represents the distance. But in statistics, that's too easy. We don't do it that way. To make these values positive, we actually square them. So we take those differences, mu minus x, and square each one. So the first one is going to be 9 squared is 81, and then 8 squared is 64. 0 squared is 0. Negative 2 squared is 4. Negative 7 squared is 49. And negative 8 squared again is 64. Now we're gonna actually average those values. So in order to average them, we have to add them up. So when we add all of those distances squared, all of these values, we're gonna get a total of 262. But then in order to find the average, we're gonna divide those averages by the total number of values, right? Which in our case is 6. So we're gonna have 262 divided by 6, which will give us approximately, rounded, to 43.6, and the 6 will be repeated. I'm going to put this into a calculator. You can put it in the calculator to verify. Okay, so this average of these square distances is actually, it's our population variance, and it's denoted by sigma squared. So this is what it looks like when I write it, handwritten by me. This is sigma squared, and this is a population variance. But you may notice this is not the actual average of the distances, because we squared all the distances, right? So this is the average of the distances squared here, and you will be correct. So in order, now we need to unsquare those distances, right? Unsquare the population variance. How do you unsquare? Well, you take a square root of it, right? So we're going to take a square root of the sum of of the distances squared divided by n. Okay, so we take a square root of 43.6 repeated, and that will be approximately 6.6081 rounded to 4 decimal places. And that is our standard deviation. And the standard deviation is denoted by just sigma without a square. So the relationship between the population variance and population standard deviation is that the population standard deviation is square root of population variance. And if you have a standard deviation and you want to find out what the variance would be, you would square the standard deviation to get the variance. So that's the relationship between those values. Standard deviation. Well, I did this with you because I want you to understand where that number is coming from and what it actually represents. That's very important, but you should also be able to use technology to calculate that value. Now, there is a very important nuance when you are going to calculate the standard deviation of a sample. I'm going to remind you that this was a standard deviation in the variance of the population. So the formula that we use for the variance of the population is the sigma, or the sum of mean minus x squared divided by n, right? Now, for the standard deviation of a sample, we're going to use a different letter. It's S, and the formula will vary slightly. So it's the sum of x bar minus x squared, x by squared. We're going to divide by n minus 1. So we adjust the denominator for the variance of the sample. We reduce the denominator by 1. When in the formula for the variance of the population, we do not reduce it by 1. Okay, and therefore, that is why in your calculator, you're going to have 2 different values. So remember earlier, we had our student heights in list 1. And when we went to calculate statistics, we hit one variable stat and then list 1, frequency 1, calculate. Remember, we had the mean, and then we had S sub x, and we also had sigma sub x. So if the values in your table represent the population values, you would choose sigma sub x, which is 3.5949. And if those values represent a sample, then you would choose S sub x, which would equal, which would be slightly larger. It equals 3.53, because that is the sample. They use the sample formula to calculate that standard deviation, where they reduce the denominator by 1. So pay attention when doing your homework, which value you should use. Now in StuckCrunch, it's also going to be different. So if you want to calculate your measures of variation in using StuckCrunch, So your variance and your standard deviation, that refers to sample. Now, if you want to treat your data set as a population, then you're going to scroll down and you're going to have unadjusted variance and unadjusted standard deviation. So unadjusted, that's for the population. So again, we have our values of a standard deviation of 3.7306, just like on the calculator, and 3.5949, again, just like a sigma x on your calculator. Again, just a reminder, these values have nothing to do with the example that we just did in this video. It goes back to the example that we did a couple of videos back. So in this slide, you see the summary of the formulas. So the formula for variance, the population versus sample, and the standard deviation, population versus sample, the symbols and the formulas. So a couple of notes that summarize what we just learned. Says sigma has the same units as the original data and therefore can be used as a measuring stick. Roughly speaking, the standard deviation measures variation by indicating how far, on average, the observations are from the mean. For a data set with a large amount of variation, the observations will on average be far from the mean, so the standard deviation will be large. For a data set with small amount of variation, the observations will on average be close to the mean, so the standard deviation will be small. So basically, your standard deviation also kind of tells you, gives you an idea how big your range is going to be. So if the standard deviation is small, the range is small. Your data is not spread out. If your standard deviation is large, that means the range is large. That means that your data is spread out. So in the data where all values are the same, the standard deviation is equal to 0, as there is no variation. All right, we're gonna use this later, but for now, just take a note of it. And I would like you to practice what you learned, and here's a problem for you to practice. So below you have two data sets, and those are waiting times in minutes of customers at the Jefferson Valley Bank, where all customers enter a single waiting line, and the Bank of Providence, where customers wait in individual lines at 3 different teller windows. Find the range, variance, and standard deviation for each of 2 samples, and then compare the 2 sets of results. All right, let me know how it went, and I'll see you in the next video.